Okay, Assalamualaikum and good morning. So, um, how are you today? So, as you can see from the chat box, I wrote that I'm going to start in the 10 minutes. Okay, now I am ready. So, we're going to start on our next subtopic in the chapter 3 on the instrumentation. Okay, the instrumentations which I like to discuss on this morning is on how this instrumentation can help you in a way of monitoring for any kind of construction project. Okay, what is the instrumentation actually? And then how do we deal with the instrumentation's technique or methods? And how does this instrumentation will be helpful in order to give you some informations data regarding on the construction process, and then how this data can be interpreted in order to do some kind of design and analysis. As what the important about the instrumentation is on how we can control it, any kind of the structural failure or any kind of geotechnical structural failure in the future. The thing is that when we have the some of the instrumentation data monitoring on the field, mostly we can use to predict what will be the occurrence of the failure. Is it can be happen in the next few years? The cycle of the failure on the site itself. So I'm going to share to you on this topic on the monitoring and instrumentations. So actually, these two things are quite relevant each other. So what we're going to see on that part is how this thing or the instrumentation and monitoring will be more helpful to prevent any failure. So in a way for this morning, we are focusing on the geotechnical failures. If talking about the geotechnical failures, I am believe and sure every one of you might familiar on type of the geotechnical failures such as settlement, differential settlement, bearing capacity failure, slope failure, sliding failure, overturning failure. Whatever on geotechnical applications on slope stability, and then also the foundation itself. And if you are dealing with the embankment, road construction embankment, and then you are dealing with the dam constructions, how are we going to monitor or to get the info from the site itself? For example, if you are looking for the pore water pressure, the level of the water level, and how do you get the info from the site? Are we going to use some sort of the tool or equipment to measure the water level? So now what's the importance of this measuring? How do we interpret all these informations in order to calculate the settlement itself? For example, if you are constructing a embankment and then an environment, and you have a proper things tool to monitor the displacement, the vertical displacement, for example, by using the inclinometer, and then you have some sort of the piezometer. So these are the functions that when we have this tool, it can give you some information that we can calculate on the total settlement, for example, for instance. And then you can also estimate the pore water pressure and what is the effective stresses. So all those things, when we have this information, it is easy for us to calculate on part of the geotechnical aspect. And then not to forget, talking about this technical informations, what's the important, for example, if you are dealing with the settlement, what are the formula, and then you have to know the theory, concept, design behind the info itself, and then what are the important things on the technical aspects such as the stress consolidation pressure, the pre-consolidation, over consolidation ratio. All those parameters obtained through the experimental or from the on-site monitoring data. So who has this problem? Mostly geotechnical engineers or any consultants or constructor that dealing with the geotechnical application, we face this problem. And again, the problem will be not similar to any site that you are dealing with. So some failures cannot be predicted, or somehow the failures are not giving you any sign that will be happen. So you must ready in terms of the preparations, avoiding any design or technical errors, and then how, if the problem has occurred, how are you taking the mitigations work, and then how do we interpret or integrate between the mitigation technique and also the instrumentation technique. So these are comes together and combined to give you the important technical data for the analysis and for the future design and development. And how or why should this problem be solved to avoid any future excessive failures? And then how will the know that the problem has been solved using the mitigation technique through the instrumentation for controlling and monitoring on the construction activities. Okay, what is the geotechnical instrumentation and monitoring? So actually, these are the information that you can find through the any website. For example, any geotechnical company services that provide their technical service on this kind monitoring, mitigations, instrumentations. So these are the companies that can give you or providing you a set of the equipments or a set of tools that able for you to collect all the informations data on the site. For example, as I mentioned, we also can have inclinometers, piezometers, beam sensors, or anything that you are looking for. It's back to what's your objective doing this, or what are the things that you want to measure at the end of this thing. For example, if you are looking for the vertical displacement, you have to choose the right tool or the right technique or any instrumentation methods that can provide you this kind of the data. For example, if you wrongly choose this tool that will not giving you the right information, this is quite unlucky. Somehow the process of instrumentation must be placed on during the construction activities, during, before, and after. For example, again, if I take one geotechnical application in embankment, construction of the embankment, we want to estimate the vertical displacement before, during, and after. Because the thing is that when you place any loadings on top of the embankment, the answer will be having some kinds of the movement in the vertical directions. So we want to estimate, is it the vertical displacement keep increasing, or it's already constant for the time or for the specific loading that you have applied on. So these are the important. We are not using some I mean that if you are choosing the right tool and the right measurement that can give you the right data and easily for you to do on calculation and design analysis. Okay, the instrumentation and monitoring technology are increasingly used to monitor structures, process and infrastructure under construction and during the operational phase in order to verify design and planning and detect events in order to reduce risk. It is used for measuring displacement of adjacent buildings, utilities, and excavation support system in urban and suburban environments of slope failures and dam construction in rural or semi-suburban area. So the equipment or methodology that will assist in accomplishing the measurement and performance evaluation of this system. So this is what we call as a geotechnical instrumentation and monitoring. If you are doing on this part instrumentation for structural or any kind of the civil engineering discipline, there will be offered to you different approaches to have for monitoring and instrumentation technique. So we cannot say that some tool or methodology can be similar or some will be different according to the objective of your work or activity. If you are looking for the what we call it as the gap of the crack, so what's the best tool or what's the best equipment that can provide you the information on the crack line, for example. And then if you want to see or to observe the crack pattern, what are the tool or techniques, methods that can be adopted to give you the information on the crack patterns. So it says that the instrumentations and monitoring is very important. We couldn't take for granted if you are doing on the analysis and design stage. Because of what? Some information couldn't be accessed through the experimental work. And then some information must be obtained from the on-site testing, for example, standard penetration test, and then during the construction itself, as I said here, inclinometer, piezometer. So those are the what we call it, the process of having these data through site investigations. Okay, the types of geotechnical monitoring and instrumentations. So these are some I just shortly shown to you a few examples of instruments in geotechnical monitoring and instrumentation, such as total station for positioning monitoring. So other than that, you also can have inclinometer and tilt meters, and then the piezometers, and lastly vibration monitors. So these are the 5 instruments that can be adopted in our geotechnical monitoring instrumentations. What is exactly the total station for positional monitoring? I believe that some of you have seen on this tool or equipment, what we call it as a theodolite. Remember back what have you experienced using this equipment? Any one of you has experienced?
Yes.
Oh yeah, good, right? Because have you attended the industrial placement or industrial training? So I am not sure
It's more in
either
civil
you.
classes.
Oh, right. Okay, building services classes. So the good about this tool is, right, we can estimate the length of one point to another point. I mean that if you have many stations using the theodolite, it can give you a distance and then the coordinate, the locations of this station. So for example, if you are planning to construct a road, so this is the tool and the other equipment that can be combined together to give you some sort of the data. So the functions of this total station for positioning monitoring is used to measure of excavation support system, adjacent structures, settlement of fields, and movement measurements of critical infrastructure. So it is manually operated or automated with the use of robotic. The laser acquire measurement functionality allow easy data collection from long range setup to adjacent buildings, structures, support or excavation system. So remember, I think that during my time, I used the manual theodolite. So it quite that we need some group of friends in the some group of friends to help each other collect the data. For example, one will handle the theodolite, the other one will record the data. So those are the manually processed. Now if you have digital or any what we call it computerized, that's easy for you to collect the informations on site. It's not anymore carrying heavier equipment, bring one this set equipment to one station. It's very what we call it, very tired activity for one day in just to collect this kind of data, the positions of adjacent building. So I think that it is very interesting if you have a time to do this measurement or measuring, collecting all those type. But again, it needs a teamwork effort. If you are doing alone, and then or you just a sleeping partner in your team, there will be no not good lah, because you are not understand what exactly how this equipment operate or works to you. And by having this kind of the tool or experiment tool or instrument, they can give to you some sort of, as I said lah, to estimate the excavation's influence or any other movements. So these measurements are then compared with the measurements of coordinates inside the zone of influence to calculate any displacement of structure. So any incidences or trends outside of project specific threshold are relayed to the project team. So with the capability to automate data collection with real-time accidents alerts to project teams can be employed. So you can search from this site, www.ecslimited.com. So they give to you details, services or informations, what are the types of geotechnical monitoring instruments. Okay, similarly to this one, the next equipment or tool that can be used for monitoring or instrumentation is inclinometer. Inclinometer monitoring system includes a manual probe or in-place sensors, cable and cable reel, and data collection readout. So with manual inclinometer readings, the probe is put into and installed semi-rigid casing behind an excavation support system. And readings are taken at a specific interval vertically behind the wall or within the slope. So these readings of tilt are then compared with initial readings, and a profile graph of lateral displacement can be produced. So looking at the right side of this slide, you can see a person, a technical staff, putting a probe, putting a sensor into this probe, and then the probe with this sensor we bring to the site location and to monitor and read the data on the movement, the lateral movement it says here. And the applications of the inclinometer can be seen on the slope monitoring. For example, if you are looking or observing the movement of the slope mass or the slope failure, so we can put in the inclinometer on the slide potential slip circuit, slip surface. So these are the functions of the inclinometers. How about the tilt meters? So similarly, the tilt monitors are affixed to the structures and used to measure the tilt of the wall or other structural member, which can then be graphically plotted and compared with the baseline initial tilt and then compared again with the project-specific movement criteria. Okay, for more understanding, view, etc., please take your time and effort to search on the YouTube to have some idea how the installation works, because we are not dealing directly on the site. I mean that we are not the technical support who in charge on sites and to do the installation process. However, we can have some idea how the installation can be done on site by these persons, and you can see that the reading data collection within the time periods. Is it we collect every day or is it we collect within the 5 days? So these are the information somehow can be accessed or can be found through yourself. Okay, the next one on the piezometers. The piezometers can be used in a variety of construction applications, both urban, suburban, and rural. So the applications include large soil field sites, excavation with slurry walls to monitor the performance of the slurry against water intrusion, dam construction to monitor the performance of the dam against weep and water level changes with the dewatering operations. So the piezometers consist of small cylindrical tube with a diagram, plunger, and electrical measurement devices within the rest of the body of the device. So when inserted into water level pipe or grounded in place installed, these devices measure water level or pore water pressure. So the amount of pore water pressure, for instance, can then be compared to the initial pore water pressure to understand the changing subsurface conditions and effective stresses. So again, as I said, piezometers are very important to give you the water level data. What's the effect of the pore water level changes on the effective stresses change, and finally you can have the consequences when you are calculating for any geotechnical applications such as embankment, the effect on the strength. Either you have the effective stresses or the total stress. Okay, the next one on the vibration monitors. So the vibration monitors are typically used in measuring construction-related vibrations in adjacent buildings or other on critical elements to minimize the effect of these vibrations. So typical use cases include monitoring of adjacent structures during adjacent demolition, by driving, general construction-related vibrations. So remember, in the geotechnical course, if I am not mistaken, in this topic, chapter 2, subtopic chapter 2 for PI foundation, there are some subtopic that explain to you the installation process of the PI. So during the PI installation, we also can place on the this monitoring or instrument for measure the displacement and then to measure any changes on the subsoil. Against that, vibration monitors nowadays, since some area have been subjected to the earthquake seismic effect, so we can also measure the wave below the soil structure. We call it as a wavelength. So the vibration monitors is very important to look on the what we call it the transitions of the wavelength between one particles of the soil or from the rock connections. So in terms of the calculations, you can have some sort of the effect of the seismic on the stiffness of the material on the G shear modulus. So um also, if I am not mistaken, for topic in the topic soil mechanics, there is a subtopic that telling you on the subsurface exploration technique, subsurface exploration technique by using the ground penetration radar, and then we also can use the seismic wave equipment to give some sort of the subsurface profile. I mean that through the seismic wavelength, we can tell you that is it the subsurface of the soil having high density or low density. So, and this is we not discuss more. At the paragraph here, the vibration monitors consist of geophone connected to a small data collecting readout. So the devices record vibrations over a set period each day and can be programmed to provide email alerts and record vibration exceeding a project-specific threshold limit. So now, by integrating of the Internet of Things, all those things cannot be anymore as difficult compared to the last year's period. I mean that last time we did on the data collection monitoring manually. We went to the site within the time just to collect or just to observe the water level, for example. So you install the probe into the soil ground and then you record the water level initially, and then you coming back next 5 days to see is there any changes of what we call it the water level in reduce or increase by the time, and next we come back again. So that were very tiring process because we came to the site many times. But now, when we have some sort of the internet that we can observe this data off-site, no need go to the site just to collect on the period of time. We monitor from far the site through the internet or from any kind of the program software. That's are the good things about the IoT. Okay, I show you here one of the application on the slope monitoring. Actually, there are many things. There are many applications that can be adapted for monitoring and instrumentation techniques. So, this is the image on the right side, indicating to you how the inclinometer has have been installed on the site. So, including to the potential slip surface or slip circle here. Why do we do that? Because this is the critical slip mass that can prone to the failure. So the inclinometer will be telling you the displacement, the movement of the soil mass itself. So the slope inclinometers are devices developed to monitor and measure the deformation of the subsurface. They have been widely used since the 1950s to evaluate the performance of natural slope embankments and retaining walls, providing significant data about in-situ ground movements that could be an indicator of potential failures. So the inclinometer were originally utilized to monitor landslide deformations and assess slope instability. Nevertheless, they are currently used to evaluate more complex interaction, such as the effect of excavation on nearby structures, deformations of the building, and settlement of embankment and roadways. So more specifically, the installation of the slope inclinometer serve the following scope: determine whether they are isolated or extensive deformation patterns within the slope, derive whether the deformations are accelerating, decelerating, or develop at a steady rate, check that the deformations are within the limits established for the project during the design, verify the stability of the slope, or give a warning about a potential failure. So these are the four objectives why we are doing the slope monitoring. Something that can be prevent from future failure. And I think that I have finished for this online class, and for further reading or further explanations, and I hope that every one of you can access through the YouTube to understand how the installation works. And not to forget, every one of you, please complete the learning activities from the week 6 to the week 9, because we're already in the week 9, and next week is the week 10 before you have your festive season leave or holiday. So please complete all those activities. Just give you some idea of how do you do a forensic engineering study from the case selected. Okay, do you have any question? Ada soalan tak? So jangan lupa ya log in to YouFuture, and then sign in for your attendance today. And lastly, learn activities. Do you have any question?
Madam, untuk yang learning activity tu, kan dia ada week 6, week 7 satu aktiviti, week 8, week 9 satu aktiviti kan. Kita kena buat setiap week tu satu video dengan satu video presentation ke? Tu kita combine buat.
Dia macam ni lah. Okay, macam week 8, 9 saya set untuk apa failure jenis slope failure ke dengan debris apa. So week 6, 7 tu saya set for differential settlement, kemudian excessive settlement and excavation if I am not mistaken. So let's say lah, contohlah, kalau kata sepatutnya lagi cantik, kalau week 6 satu file name video. Week 7 satu file name video. So, failure apa yang kita nak highlight? Contohnya week 6 you highlight untuk settlement failures. Application dia kat mana? And then week 7 you boleh highlight untuk excavation failure. Week 8 you boleh focus on the slope stability. Week 9 apa kat situ saya letak. Maknanya kata in total for 4 weeks tu adalah 4 short videos lah that supposedly you provide to me. Dalam short videos tu, I have listed all those informations required to be on your slides. Contohnya, saya tahu dalam 5 slide untuk 5 seconds tak ada banyak sangat kan. Tapi you just take it the important point. And I am doing this just to ensure every one of you understands what are important information can be inserted on your slide presentation, and then the rest can be delivered through the verbally informations or verbally communications. So mana yang you rasa boleh kita bagi tahu melalui percakapan, you tak payah letak dalam slide. Slide tu benda-benda yang penting saja untuk kita highlightkan. So in total 4 videos lah mengikut minggu. Dan saya tengok, I can track ya siapa yang dah submit, siapa yang belum submit. So kat situ is counted for your attendance actually, sebab in total our class is 3 hours kan. So bila 3 jam, contohnya this morning I have finished our class in 45 minutes for example, or 30 minutes. So what's the remaining activities you are doing for the remaining class? So this is the time that you can complete all those activities given to you from the week 6, 7, 8 till now 9. So there is no excuses that you couldn't do. I am not sure what you are doing, or you don't know what to do, because my approach, saya pun tak pasti macam mana Encik Bat bagi pada awak dulu, but the other class yang saya in charge, the previous lecturer did similarly. So the students need to do on summarizations for selected case study, case failure, and then they post or upload in the Microsoft team. So that's how the participations engagement for your class sessions. Kat situ kita akan tengoklah awak punya penglibatan untuk direkodkan dalam kehadiran. So macam mana last time dengan Encik Bat?
Kita orang buat face to face.